Continuing with the 6-3 lesson, our next example is going to continue to work with a lot of the same ideas for us. We are going to treat this as our old figure and this as our new figure, just to, whoops, I did that backwards. Our new figure to our old figure. And so our scale factor here is 5/25, or 16/80, or 3/15. Those all reduce to 1/5, which makes sense because moving from old to new, my picture is getting smaller. My scale factor should be a fraction less than 1. If my scale factor is a fraction more than 1, I'm increasing the size of my picture. So that's always something to keep in your mind. Now, surface area of a rectangular prism is kind of a cumbersome formula. Remember, it's 2 times the length and the width plus 2 times the height and the width plus 2 times the length and the height, basically 2 times all the dimensions. Area. We expect, when we get done, that these are going to compare by a factor of k squared, which will be 1/25. If we take a minute and just work these surface areas out, surface area of A is going to be 2 times 5 times 16 plus 2 times 16 times 3 plus 2 times 5 times 3. That will end up being 286. The surface area of B is 2 times 25 times 80 plus 2 times 80 times 15 plus 2 times 15 times 25, and that will end up being 7,150. All I did was went through and took 2 times each of the dimensions in succession. If I compare these as a ratio, I'd have 286 to 750, and when you reduce it, it does end up being 1/25 like we want it to. Volume of a box is an easy formula. If you remember, the volume of a box is length times width times height. And so we run through and take care of that. The volume of A is 5 times 16 times 3, which is 240. The volume of box B is 25 times 80 times 15, which is 30,000. Now, since this is volume, I do expect that these are going to compare at a factor of k cubed, which would be 1/5 cubed, 1/5 cubed, which is 1/125. When you put these guys into their ratio, and you have 240 over 30,000, and you reduce with your fraction, you end up with exactly what you think you should. The summary of all of this is that anything one-dimensional, length, perimeter, or circumference, is going to compare at a ratio of k. Anything two-dimensional, like area, is going to compare at a ratio of k squared, and anything three-dimensional is going to, like volume, is going to compare at a factor of k cubed. Now, if we are given triangle ABC is similar to triangle MNP, and we're given the perimeter of ABC is 150. We have no idea what the different lengths are. We just know the perimeter. Sketch yourself a quick picture. ABC, MNP. Perimeter here is 150. What is the perimeter of MNP if it is 3 times larger? So that means our scale factor to move from the old to the new is going to be 3. And the way we move from old to new is we multiply. So the easiest thing that we can do here, we could set up a ratio, and our ratio would be 3 over 1. Remember our new to our old, which is equal to triangle MNP, that's our new one, over triangle ABC is 3 over 1. For every 1 unit of ABC, there's going to be 3 units of MNP. And we can make a ratio of 150 is ABC's perimeter to the x we don't know. That seems like a lot of work, but ratios always work. When you cross multiply, we know that it becomes 450 units. But it is okay to just multiply by 3 because it's a one-dimensional measurement. Now, part B goes to a two-dimensional. So we're talking about area. So we're still talking about new to old, so I'm going to keep the new on top. But if I want the area of triangle MNP compared to the area of triangle ABC, I have to use k squared. So if k equals 3, then k squared is 9. And since we can put whole numbers over 1, we can do that. This is the value I'm going to use in my ratio. I'm going to say that 9 over 1 is equal to, I know MNP's area, put that on the top, over y. Now y should be a smaller value because it's to the smaller triangle. Cross multiply, 9y is 48, and y is 5.3 units squared. Now we're going to switch to volume. Volume is three-dimensional, and there's our volume of our first can. Now the volume of a similar can is half as big. Now tall is a one-dimensional measurement, so this is giving me that k is 1/2. Now the 1/2 tells me that I have the small cylinder on the top compared to the larger on the bottom. Okay, so for every 1 unit in the little one, there are 2 units in the big one. So that's my k. But I'm talking about volume, and volume is k cubed. So if I take 1/2 and I cube it, I have 1 cubed over 2 cubed, which is 1/8. 1/8 is the value that I'm going to use in my ratio. So I'm comparing volume, so I'm going to use 1/8. The volume of a cylindrical can is 210. The volume of a similar but smaller, so that means my 210 is going to go on the bottom. The one I don't know goes on the top. Cross multiply. 210 is equal to 8x. Divide both sides by 8. 26.25 units cubed for the volume. Now this last example is really going to test you. Figure 1 has a volume of 5 units and a surface area of 4 units. Figure 2 has a volume of 40 units cubed. If figure 1 and figure 2 are similar, what is the surface area? There's a lot of information there. First, I'm going to make myself a note. All of my comparisons, I'm going to do figure 1 compared to figure 2. Now, I need something to set up my initial proportion to work with. I'm given the volumes of both of these figures. So that's where I'm going to start. And when I compare volume of 1 to volume of 2, I'm really doing k cubed, and that is going to be 5 over 40, which reduces to 1/8. Now, I want to compare surface area, and area is k squared. So the only thing I can do, number 1, we're going to set up our ratio. start. And it's what we did. Now, number 2, we are going to find k. There's no direct way to go from k cubed to k squared. We have to go all the way down to k and then square it. So I'm going to k cubed equals 1/8. We undo cubing by taking the cube root. And so k is 1/2 because the cube root of 1 is 1 and the cube root of 8 is 2. Now that I know k, we are going to find k squared and set up a proportion because I want to know area and area. And so I have k squared is equal to 1/2 squared, which is 1/4. So 1/4 is equal to, I know the area of figure 1. And since I put figure 1 in the top, I put it there. What I don't know, I give a variable. And y is equal to 16 units cubed. That is it for today's lesson.